Welcome to the Generative AI Innovation Incubator. I'm very excited to bring our panel on finance and economics to you. Many of our community members have submitted questions, and we'll be addressing those as we get into the interactive part of our panel. I'm so excited to hear about the very concrete ways in which generative AI is already being applied and plans for application in this particular area. And I think we have a really great set of panelists for the discussion. I just want to remind people that we have kicked off our hackathon series. There are events that lead up to the actual hackathon days, which will be, towards the end of the summer, but there are ways that we're already starting to activate them. We are done admitting people to the first of those hackathons, but registration is open now, both for medicine and public health and finance and economics. I will say that last week, there was a little glitch with the registration links on the website, but that's been fixed. So we strongly encourage our community members to go to the website and register for our hackathons. This is a great practical way to start to form teams and work on problems in this space. We have 3 exciting upcoming talks, one by Eric Shing, that's in the computational biology area, then Manuela Veloso in finance, and then Jill Lehman is going to come to us and is going to be giving a talk that's coming from the perspective of her work. She's been working for decades in artificial intelligence, but she's also a speculative fiction author, and she'll be talking about separating truth from fiction. We had 3 tutorials that are part of this series, and one of them happened last weekend. It was really well attended and went very well. We have another one this coming Sunday, and then a final one on July 18th, and we're still taking registrants. So if you want to gain some skills hands-on with mentoring from a leader in the field, go ahead and sign up for our tutorials. We also have our past events posted on the website on the events page, and these have videos of our past events. So if you were not able to attend something that we've already had, most of those recordings are up. Some of them are still being processed. So I think that overall our events have been very well attended and are very popular. And if you've missed something, I encourage you to go and catch up. So today our theme is this a brave new world or just building on an existing foundation? Some people call large language models foundation models. We want to talk about different perspectives, and I'm very pleased that our panel actually comes from a wide range of perspectives on the topic. Also, some more grounded in applications in the area of finance and others more in the area of economics. So I think that we can bridge this space well. But I like this quote from one of our community members, and I think that it really highlights a theme that has been underlying the entire series of events. There's a lot of hype out in the media, both on the positive side and on the negative side. And we really wanted to ground this in reality so that we can think about what are potentials of this technology, but not be afraid for some of the big fears that people have had that I think are probably overblown. But there are things that we should be concerned about, and also especially how our misuse or misunderstanding of technology may be the cause of some disruption and uncertainty. That just highlights the extent to which, as we have more discussion, as we get more educated, as we get more involved and take responsibility, we can control the future of this. We can make it a productive future if we work together. And that's really what this whole series of events is all about. So today in particular, we're focusing on finance and economics. We have Sameena Shah from JPMorgan and Chase, David Rosenberg from Bloomberg, and I'm told there are 2 David Rosenbergs. We have the David Rosenberg who's much more expert at artificial intelligence. So just wanted to highlight that. John Horton from MIT, Sean Welleck, who's currently at AI2, but we'll be welcoming him to Carnegie Mellon University in the coming academic year, and Anton Korinek from Brookings and University of Virginia, who will be joining us a little bit late. And so with that, I'll turn it over to our first panelist, Sameena.
Thank you, Carolyn. I'm Sameena Shah, and I'm a managing director at JPMorgan Chase. I have two roles there. One is a much more research role where I lead the NLP and AI for technology teams in the AI research group, which is headed by Manuela Veloso. It's a firm-wide role. We build AI technologies for the firm. Then I also have a second role, which is a business role where I lead the product and transformation teams for a client onboarding. So anytime any entity needs to do anything with JPMorgan Chase, they go through our processes. And from my own background, I am an AI person. My PhD was in ant colony optimization and machine learning. And since then, I've worked mostly in the area of NLP and AI for technology, mostly in the space of replacing and augmenting human knowledge work by using AI processes. Carolyn, did you want me to go into the talking points also, or we'll do those later?
Yeah, just give like a very brief soundbite about what is your position and message to the world.
My main message is that I'm personally a convert. When I first LLMs came out, I thought it's going to be like BERT 2.0 or 3.0. It is much, much more. And we have been having a lot of success in some of the feasibility and benchmarking studies that we've been doing. Having said that, I do think from some of the practical use cases that we have to implement at the bank, the accuracy is often 100% required, and we cannot have any hallucination or anything like that. We have to provably show things from a control perspective, and we are pursuing a number of research directions to allow us to do that. A second thing, which I will also say, is that there is a lot of discussion on what is, who's finally accountable for mistakes. I think it's still humans. We are finally accountable, but there is going to be a lot of job flux that will unravel because of this innovation.
Great. Thank you so much, Sameena. David.
Hi, happy to be here. I'm David Rosenberg. My position is head of machine learning strategy in the CTO office at Bloomberg. My background is in statistics and machine learning. These days, briefly, what the CTO office does is kind of determine what new technology areas to concentrate our resources, both in terms of kind of capital investment and human time investment, and trying to see what's coming and do a little R&D to make sure that we stay on the cutting edge. So my focus recently has been, on the one hand, differential privacy, which is not so relevant today, but large language models. I was on the team that built Bloomberg GPT, which is our internal large language model trained kind of half on public data and half on our internal data at Bloomberg. And it was a research project, and we're kind of going through the experience now of seeing, in some sense, what can we do with it. And I'd be happy to talk more about that. But I'd say my message is to, in some sense, meet large language models where they are. There are certain things that they are clearly good at. Focus on that. Don't try to make the large language model solve your whole problem all at once, whatever that is. Kind of be realistic, set realistic expectations. And yeah, they're wrong. So make sure you use them for things that are easy to check.
Great. Thank you so much. And John.
Hi, I'm John Horton. I'm an associate professor at MIT Sloan in the Information Technology Group, and I'm an economist by training. I'll try to keep it short. I would say if I had to have a message for the world, I'm not a technologist, and so it's very difficult to say, okay, this is the future. These are the kind of tasks that these things are going to, replace. But given what they can do now, it seems likely that some human tasks would be replaced. I think it's important to, with any new technology, to try to think about what are the human skills that this, maybe it substitutes for some, but what does it complement? And right now it seems like it puts a high premium on asking good questions or prompting, and knowing how to interpret the results that come out of this model and decide if they're appropriate for your use case. So to kind of piggyback what David was just saying, they do make mistakes, and knowing how to kind of assess them and refine seems to be important. Being an economist, my focus is largely on productivity effects, it does seem that they can speed things up. And so some of the studies that are coming out about, say, like people using Copilot and having these like large productivity increases, that's fantastic. I think one thing that I'm particularly interested in is how does it expand the things that a person can do? Not just, the people who used to do it before are now doing it faster, but does it allow people to do things that normally they would have either had to delegate or get some help with?
That's very exciting. And finally, Sean Welleck.
Hi, I'm Sean Welleck. So I'm a postdoc right now at the University of Washington in AI2. And I'm going to be starting as an assistant professor at CMU in January. And so I come from a machine learning and NLP background. My research is in that area. And so I work on some of the core algorithms that are used to train these large language models or generate things with them. And then I've been particularly interested in what are kind of the uses of these types of models in areas that we need kind of high assurances on things like correctness and accuracy. So one in particular is what role could these play in things like mathematics, where we really want things to be correct. And so my kind of takeaway message is that these language models are incredibly flexible. So a lot of different tasks can kind of be viewed as, take some text or code as input and produce some as output. And so I think this could ease access to different kinds of information. So let's say I want to teach myself how to program something really common and simple in Python, then maybe this could be helpful for that. On the other hand, it's really important to keep in mind what are the limitations. And so one way to think about this is that these models are very good at producing things that look plausible, but not necessarily things that you want to trust. So they don't have guarantees on things being correct, information being up to date, and so on. And so keeping that in mind when we decide where to use them and what research to do next is, I think, really important.
Great. And I just want to point out that one of Sean's specialties is working in the area of large language models in math. And of course, computation in the quantitative space is really important in both finance and economics. And so I think he has valuable information for this panel. Anton Korinek will be joining us a little bit late, so we will have his introduction when he comes in. And I think that now we'll move into our questions. I have 3 slides worth of questions submitted from our audience. And so I will go ahead and get started with that. So you can spend most of the time hearing what our panelists have to say about these things concretely. So our first question is, from your circle of awareness, and I acknowledge that our panel is coming from a wide variety of perspectives, and I think that's valuable for our discussion. Where are we at between concept and application? Some of you have mentioned specific applications already, but I think that in our broader discussions, we've talked about things that, we're just at the idea stage, or things that maybe are ready to be deployed or not, or about to be. I'd like to hear sort of where you are at with specific things that are on in your sphere of awareness. Some policy members who have actually registered for our events have said this topic is becoming a matter of interest to policy makers, which suggests that in that sphere, it's not about jumping on something right away to make huge changes in the near term, but yeah, we're considering this. It's a little bit more at the idea stage, but I'm also hearing about things actually getting off the ground with startups, and some people actually submitted their comments to that effect. And I wanted to kind of go across the panel and just get your sense from your sphere of awareness and influence, where you're focusing on this landscape. Let's start with Sameena.
So I think from my perspective, first I'll begin with saying that, whatever thoughts I'll share, they are like my personal thoughts as a researcher, as a person who works in the applied space as well, not necessarily the viewpoints of my employer. So with that caveat, I think there are a lot of applications, and it is certainly from my perspective moved much beyond an idea stage. So in my group also, we have conducted several benchmark studies, several feasibility studies, and I think one of the panelists said this before as well, that there are some pockets of use cases in which it is exceptionally good. And I would say it's like much better than humans. And there are some pockets for which it's not well suited. And there are some use cases in which we are exploring, like I think one of the questions is also like asking, hybrid kind of approaches. So I'll give an example of each. The one use case, which I think, in fact, like two use cases in which we found it to be extremely good from, the experiments we ran, was one is, we often get like all these policies which are in legalese, and then they at some point have to be converted to code, which gets implemented into our application systems. Now, the time it takes for somebody to understand that policy and for it to be finally implemented in code, there is no one human who can understand legal language as well as write Java code. So it requires a number of hops and a number of functions of each who will be like a translator between like this step to this step, and then from this step to this step. And the steps could be, okay, you could have a legal person in compliance, then you will need a legal person with the domain knowledge of the application. Then you will need a product person to write like some version of what needs to be implemented by technology. Then you will need the technologist to pick that up and like write it in code. And then you will need all the back steps to be able to then like explain back. So it's a very laborious and a very time consuming process. And it's also error prone just because the number of hops that can get introduced. But actually AI and LLMs can understand both legal language and Java code, like especially the ones that we have now. So we experimented for some of the simpler use cases, and the results are like very, very good. And then in those use cases, you can actually see what you code have implemented today and the code that got generated and measure it on output. And these are things that are highly, highly regulated. So we have very good controls and excellent like testing mechanisms already set up for those. So I think if it passes those kind of tests, and it is able to do that for some of the simpler use cases, like that, I think is a good win for us. And that will be area we will continue to explore on and use. And then I'll give you an example of hybrid systems. So in one of the cases, for example, I mentioned that we would need 100% accuracy, which is often like common for like regulatory environments, that you would need actually 100% accuracy for many use cases. So one, let's say, you do some like public information screening. Theoretically, these models should be excellent at that because they have been trained on a lot of public information. However, because of known hallucination and known like generation of plausible things that look plausible but are actually not factually accurate, that is a risk. So what you could do is then have an ensemble of methods, and then you could also like create systems that actually generate the evidence. So you could have, okay, where are you getting this from? Get Google search results, LangChain, and pass that through, and then go to the link, take a screenshot of whether the evidence was there, use some traditional, and I shouldn't say traditional, but like standard document multimodal methods that we use to extract that information, generate the result, and see if there is a match or not a match. If there is not a match, raise it to a human to validate. So you could have these type of hybrid systems also to increase your accuracy. And then there are things which are, it's just like, you don't have proper controls, you don't have proper testing, and there are evidence of problems already established. And I think one of the cases Carolyn and I were also discussing, we have a person of which we are co-advisors, and one of her results was actually like her model far surpassed all of these other LLM-based models. So there are these specialist types of use cases in which non-LLM style models still outperform by a vast majority. And these specialist types of tasks often will require a lot of fine-tuning, or some of our current approaches, like, just keep going more and more in those directions, and will continue to be better.
That's great, Sameena. I think on all counts, I note that Shashank from our audience has posted a question right along the lines of something that you included, which is what can you do if you're in one of these applications that really requires higher accuracy than you can trust that you'll get from these large language models. And as we go down the line to our other panelists, please feel free to bring this strand into what you are sharing along these lines. So again, what we're discussing right now is, where are you on the spectrum of, kind of, we're considering this, we're thinking about what the potential might be, all the way to we're already deploying it in our system. David, you can go next.
Search for the unmute button. Great. So as far as where we're thinking to deploy these, as been said many times, and I'm sure we said more, is that these things hallucinate. And so kind of like two directions to handle this. One is use it in a setting where there's a human intermediary who can, see issues and resolve them. And so along those lines, there's kind of excitement on doing things like, code completion, and for coders, unit test generation and doctrine creation. Okay. There's also the assistant for a help desk person, for instance, right? Like suggesting responses that can accelerate, kind of giving help to people who ask for it. So this is all on the human intermediated side, and you could probably think of many more. One that's not quite in that vein, so I'll mention it for interest, is where we already have a pipeline for handling a solution, maybe say a standard machine learning pipeline. What does that mean? We have like kind of training data, and we have a well kind of thought through test set to see, like, is this solution ready to release with our product? Is it ready for prime time, so to speak? And if you kind of already have a nice setup where you can kind of verify correctness in some statistical way, then I'll tell you one thing specific we've been thinking about, where we've been experimenting with, I should say. In a setting where the problem is, say, expensive or laborious to get human labeled data, but it's not so hard that one of these, super models, say like a GPT-4 type thing, they can solve it pretty easily. They don't need that many examples to solve it. Unfortunately, those models are actually too slow to deploy in useful production. Just like the compute required is too much for what we need to deliver. Whereas simpler models can handle the speed and stuff. And so the issue is the simpler models need far more examples to achieve the same efficacy as these larger, more powerful, and slower and more expensive models do. And so there's kind of a I don't know if this is general terminology, but we kind of call it like a silver labeling, where we get the very expensive model to solve the task, and maybe it's not perfectly solving it, but it generates data that's not exactly correct, but we can use that on a simpler model. And then we're not really exposed directly to the risk of GPT style models not doing well, because we have our own standard test sets to plug it into downstream. Okay, so there's two different directions that we've been comfortable using these in.
Yeah, I love that, actually. The idea that we have access to these new capabilities, but there are trade-offs, and there's no reason why one model somewhere is going to do everything for us and it's done. There's still a lot of work to be done in the space, and trade-offs to be considered, and engineering that needs to be done. And so I think that really highlights that it's a work in progress. And so I think that it's like a new, I'll try not to say a new toy, a new tool though in our toolbox that we are working on, figuring out what to do with. So John, you're coming to us more from an economic perspective, whereas our last two panelists were more in the finance space. What can you tell us from that sphere?
Well, I mean, doing research with these things, you're not in a production environment, so it'll mess up your paper, not your customers. So that's probably, gives you a little more flexibility. There's a couple of companies that I advise for, and they've been deploying some of these systems. I think consistent with what the other panelists are saying, they're for applications where there's a human in the loop to check the output. And so, cases where, say there's some writing that you have to do, and it can give you a first draft, but then, you're free as a user to kind of cut out the stuff that you don't need or modify it. And, it's ultimately a human that's saying, yes, good to go. I think things where, it really kind of comes down to the stakes to an extent. I think if you imagine some scenario where the text is, if you get it wrong, the stakes aren't that high. And others, if you're, writing a commercial contract or something, or giving information to a regulator, you're going to see something like very, very different. And so I imagine that there's probably just like a frontier of like, how good is the model, and how perfect does the output have to be, or how close to perfect does it have to be? And we kind of pick some frontier. I mean, it's not fundamentally different from what we do in organizations generally, and putting like, how many checks do we put on something? Like we delegate something, what procedures do we put in place to make sure that it's accurate? It's like an interesting technical problem, but in some ways not a new organizational problem.
That's great. And I think, this whole human in the loop aspect of it really highlights a question that I think that we're all asking ourselves still and sort of figuring out is, what are functional roles that this technology can play in these socio-technical systems where we find ourselves? And so people are still integrally involved in all of these processes. It's not as though AI is here and now it's going off and running the world, and we're not part of that process continuously anymore. I think what I'm hearing is that humans are still very much in the loop constantly. So there's a role for us, and we can also be watching then about how it's being applied, what the impacts are. We're constantly watching and constantly responsible. Sean, why don't you give us your perspective?
Yeah, sure. So I guess like one area where I'm kind of in a similar position where an error might mess up a paper versus a product. But one area where we've started to interface with people really trying to use these systems is in an area where you can check correctness. And then also in areas where there's humans in the loop. So in some sense, I'm kind of reiterating the points here. So just to give another anecdote, like in the area where you could check correctness, for things like software or even complex mathematics, there's these tools that are developed that allow you to specify something and then formally verify that the specification has been met. And so these use kind of specialized programming languages, and they're often really tedious to work with. But the nice thing is, if you produce one of these kind of proofs for your specification, then you know that it's guaranteed to be correct. And so this is an area where these large language models have been increasingly exciting, because we can kind of enumerate many different possibilities with them and then kind of just get rid of the ones that aren't correct. And they've kind of proven so far, or not proven, but shown promise in being able to adapt to this lower resource setting by kind of transferring their knowledge of all the other stuff they've trained on. And so here, I think like in the past couple of years, this has gone from kind of something that might be possible in the future to, now we're having workshops with people people who work in formalized math or with these proof assistance and self-proof verification, and starting to talk with them. So I think that's a really exciting area where if you can identify one of these use cases where you can kind of safely get rid of bad things that your model produces, then yeah, it could be really useful there.
Great. Sean, there was a follow-up question in the chat for you. A community member mentioned specialized languages to verify correctness is something that you referred to. Can you give examples of those languages?
Sure, yeah. So I guess technically, so these are called interactive proof assistants. So there's a few popular languages. So one that's used in mathematics is called Lean. And then another that's used in more in software and also in math is called Coq, C-O-Q. And then there's another one called Isabelle. And so relative to, say, like the amount of Python code that we have on the internet, these languages are fairly small. And they tend to require, more specialized expertise to work with.
Great, thank you so much. And now we will have our final panelist introducing himself. Anton, can you please go ahead and introduce yourself?
Thank you very much, Carolyn. So yeah, I was a programmer in the 1990s and played around with neural networks at the time, but you couldn't do very much with them back then. So I decided to become an economist and study financial crisis. And that's what I'm now. I'm a professor of economics at the University of Virginia and also a Rubinstein Fellow in Economic Studies at Brookings. Well, back in the 90s, I guess I had not properly internalized the power of exponential growth. And when I saw the progress in deep learning in the context of image recognition a decade ago, I thought, boy, things are changing really fast. I better pay some attention to what's going on here. And so I moved my research to the economics and governance of AI. Well, honestly, over the past 12 months, I have been even more surprised about the rapid progress. One really interesting statistic, for the past decade, the amount of compute, the amount of computational power going into training the cutting edge foundation models has been doubling every 6 months. So it means quadrupling every year, growing by a factor of 1,000 every 5 years, 1 million over the past decade. And although this progress has been pretty continuous, it seems like in the past 12 months, we have crossed a critical threshold where these systems have suddenly these broad, useful capabilities. Some people are even saying they have some rudimentary form of general intelligence. So one way that I think is useful for thinking about large language models and other generative AI, but large language models in particular, we know that they have been trained using this really banal objective of predicting the next word or the next token in all of the data in the training data set. Well, I guess one lesson that we have learned is it turns out that if you want to predict the next word in essentially the entire body of human text that has ever been written, you have to develop a representation of the world or a world model. And the way I think about the current generation of language models is that they have developed really powerful representations of the world, really powerful world models. And whenever we ask them to solve a task, they're essentially drawing on this world model to inform the output that they produce. And that is getting better and better and better. Now, I don't want to overly hype these systems. So let me perhaps also conclude my initial remarks with a bit more of a sober message. So these language models, they're very brittle, they're not very robust, not always reliable. They are opaque, they're black boxes and are difficult to interpret, and they regularly hallucinate and give incorrect answers. In other words, they're just like my brain.
Yes. So I'd like to point out that on our panel, we have all very smart people, but people who obviously have some differences in terms of their views on these things. And I think that's great and very productive, because we want to see that there can be a conversation, a rational conversation between people with different perspectives. And I think that that's what gives me the most hope, that we can work together to shape the future of this area. So I see there's some discussion going on in the chat. It seems like resource sharing, and that's wonderful. And the resources that get shared in the chats, we're going to be putting into our Slack so that they can be available for the ongoing discussions and work that this community is doing. So let me move back to our questions. So one question is, what were the major limitations of the earlier generation of large language models like BERT and Elmo in applications within your sphere of awareness that recent advances address? So many of you have said, oh, recent, especially Anton brought up neural nets of the 90s, and I was working with neural nets back then too, and so I'm very familiar with what he's referring to. But even very recently, these large transformer models have limitations, and Sameena mentioned some work at JPMorgan where there was an earlier approach trained in more traditional, quote unquote, ways, and it outperformed these GPT models. However, there are still limitations. And so I wonder if you can be a little bit concrete then about the limitations of past foundation models and how you see this new generation of large language models addressing those. And let's go ahead and start with Sameena.
It's an interesting question. So when GPT-3 had also come out, we had tested it, and nothing changed for us. We just continued on our path. But the 3.5 actually changed things for us. But it's interesting, like what changed between 3 and 3.5. So, and I think it was, mostly the RLHF loop, in my opinion, that like then changed the results to be much more what would be acceptable to a human being. That in some ways, I also wonder if it brings out the human limitations of what we can process and what we consider good and not good, and just like how kind of compact that is, because the from the best of my knowledge, the actual RLHF loop was just like 50,000 or something, versus the large parameter space that was part of the foundational models themselves. So just with like 50,000 like labeled samples, does that improve the quality of the underlying model that much? It's like kind of an interesting hypothesis of why that should happen. But the actual of why that should improve, but it should improve on a variety of different types of tasks. So I think the variety of tasks that it now performs well on is quite compelling, and it's quite surprising, because I think from a practitioner point of view, whenever we implement technologies which are non-foundational type of technologies, we would always have to fine tune, and we would always have to like do other things on top, or like start from scratch in some cases, and it would be like months of effort. But I think now what we are seeing is that the on top part could be very, very small. It could be a day, it could be a few hours. And that aspect of how squished that has become, I think is the real accelerator.
So you mentioned the reinforcement learning wrapper as being a source of the improvement that you see. I'm not sure that everybody in the audience is familiar with the term that you used. Can you just say just a few words just for our broader audience about the specific reinforcement learning algorithm and what its significance is?
So I cannot claim to be any expert on what was actually done, but to the best of my knowledge, whatever output was produced from the initial model then was shown to a human expert, and then the human expert rank stacked it and said, like, I actually prefer this output versus that other output, and whatever was the answer that the human gave was then fed back to the model to improve the output that the model was producing. So my hypothesis is, the other thing which is the point here is that while the initial parameter space and the amount of data that the base model was trained on was very, very large, but the amount of times that feedback was given and the number of times that a human was shown an output and the human gave feedback was much, much smaller and like really tiny in comparison to the base model. So that thing about this being like, ginormous and this being only like 50,000 is quite compelling, that with just 50,000 times a human or like several humans could say like, I prefer this versus that, and that when fed back, and then the output produced is much more likable for a wide range of human beings on a wide range of tasks is quite compelling.
So David, you posted to the chat about whether BERT-based models have been used in the past to do generation. And actually, I think that fundamentally the encoder-decoder model that is used in these GPT models is really not altogether different, in the sense that you can encode things using BERT and introduce a decoder, and that those representations can still be at the foundation of it. My question, I think, is really focused not at this sort of macro level, but more at the level of the representation itself. What does it capture and what does it not capture, and what kinds of specific errors were annoying errors that sort of held back the field, enduring problems that we were not able to solve, that could be part of a variety of applications, and that these new GPT models address. Does anyone want to jump in with an insight along those lines? I think Sean and Anton would probably have something to say about that. Sean, do you have anything from your work? And it could even be about how can you overcome these problems, maybe even in other ways. I know that you've done a lot of work with neurosymbolic reasoning, and I don't think that you mentioned that in particular, but it would be good to get your perspective on how the integration of scaffolding from more structured means might actually advance the capabilities of these models, and how that relates to this new generation of models. Let's start with you.
Yeah, so just to start, I think like one big difference with these models versus like prior GPT-3 models is this idea of like providing some examples in its input prompt, and then it being able to do the task to some extent. And so traditionally, like we always thought about collecting a fairly large data set, and then that data set was kind of specific to one task, and then we can get pretty good performance on that task. And like a really good example of that is machine translation, where you could have a very specialized machine translation model. And then if you ask it a question about like, I don't know, something like Python programming, it's just not relevant for that model. And so one surprising thing with these new types of models is that for some applications, you're able to kind of use a general purpose model and provide it with a small number of examples and get it to do something. On the other hand, I think like maybe this is what we're all discussing right now. It's like, how far does this actually go when you use it in a real setting for something that you really want to be correct? And so that's kind of the trade-off. But I think like one of the surprising things about the GPT-3 paper was this kind of few-shot learning capability. And then it's kind of gotten refined over time to now you have models that can respond to instructions. So that's like one major shift that's happened. And then, yeah, when we think about like using this for something, maybe just use the example that I'm familiar with. So using them in these kind of specialized proof assistants, we have found that the kind of few-shot learning can be useful. So, for example, we don't have examples of going from like natural language to some of this specialized formal language. But we're able to get the model to do something useful with a small amount of examples within a particular setting. And then here, as I mentioned, the output is ultimately verified by a kind of symbolic system, which makes this all possible. Because without that, your model is going to produce something that's unreliable. But in this setting, we have a kind of symbolic system at the end that tells us whether it's correct or not.
Great. Great. That's very informative. Anton, do you want to jump in and add some nuance here?
Yeah, I'm very happy to. I should say, first, one thing that's so interesting about your question of why these models have become more useful is that if you look at the plain numbers, right, progress has been very continuous. And yet, if you look at our personal experiences, we all say something along the lines of what Sameena articulated so well, that with GPT 3.5, these models have suddenly become really useful. Now, OpenAI isn't very open about what exactly happened at the GPT 3.5 level. There's one link that I actually thought is useful if I put into the chat that describes what GPT 3.5 comes from. And what's so interesting is that apparently GPT 3.5 is built on top of Codex, and that has somehow also made it more useful. So instead of guessing, let me say the way I think about it is there's kind of two parts. One is the power of the world model underlying the language model we're interacting with. And that has been steadily increasing, and that's a function of, parameters, tokens, compute. And then the second one is the interface, like reinforcement learning through human feedback, make it an instruct GPT model and so on. And I think when GPT 3.5 was released, there was actually substantial progress on both of these. So both the underlying world model and also the interface became a lot better.
Yeah, I think one thing I just want to highlight about what Anton has pointed out here is that these different forms of GPT models, they're transformer models with a kind of architecture around them that allows to be trained in a different way or interacted with or to behave in a different way. And they're used in differentially depending upon the needs of the application. And so again, I think there's a role for human insight and wisdom to be used in order to situate this technology within applications in a way that makes sense. And so again, it's not as though there's this ominous intelligence out there that now we're deferring to, but we're working with it as a tool and fashioning it. And again, humans are very much involved in all of that process. We have a follow-up question from the audience to Sean in particular, asking him to expand on the use of symbolic systems. Can you say a little bit more about what these systems are and how people can find out more about them and how they're used in that verification process that you referred to?
Mm-hmm. Yeah, so just to emphasize here, this is talking about like a kind of specialized area. So within the specialized area, there are these things called interactive proof assistants. And so you can write some specification in them, then you can write a proof that the specification is met. And if the kind of system, which is symbolic in some sense, verifies that the proof is correct, then you know that it's guaranteed to be correct. And so I think some people in the chat so in the chat, there's some concrete examples of this. And so, yeah, I would say more broadly, like you could think about like a less extreme version of this is something like when you use a language model and have it call out to Wolfram Alpha. Then there, instead of having a language model like do multiplication, then you can have it call Wolfram Alpha and do the multiplication. and you have some assurance then that at least this multiplication part of your output is correct. And so that's a kind of more general picture where you have your language model doing something, and then for the parts that you that it might not be good at, or that you kind of want higher assurances on, trying to incorporate these different tools into the generation.
Okay, great. So we have in this recent part of our discussion today focused on some technical issues. There have been quite some number of questions from our community that they are interested in hearing from our experts. What are the concrete ways that they're solving problems, and what are those technical problems, and finding out more about that. But to focus a little bit more in our area, one thing I'd like to do is put up a list of what are the applications in the areas of finance and economics that specific community members actually posted, and to hear what our panelists have to say about what they think are potentials or actual applications in these spaces where they either see these large language models being applied or think they could be applied, versus ones that they actually think maybe it wouldn't be such a great idea. So I'm flashing it up, and then I'll ask our panelists to jump in. Sorry, okay, great. And here we are. Who wants to jump in first? Go ahead and unmute yourself and let us know what you think. Maybe take a couple of moments to see. People posted questions about the use of large language models for marketing. And actually, I talked to some marketing people recently who had used GPT-4 to generate some materials for something that they were doing for me, and I was not pleased with the results. Others are asking things like, how could this new AI technology be used to support low-income Americans? Here, some creativity, I think, will be required of our panelists to say exactly what would be done and what do you see this model doing, or recruitment efforts, market analysis and modeling, customer service. What do any of you have to say about these applications? Sameena also already mentioned some applications in banking, and also David to some extent. Also, finally, one community member specifically submitted a question regarding B2B selling organizations. What do you have to say about any of these specific application areas?
Just somewhat related to the second one, supporting low-income Americans build skills and improve quality of life. Maybe slightly more generally, though, I'm really excited about the potential for these large language models in education and for helping people understand how to do things, how to learn new things. I've had a number of dialogues with GPT-4 trying to understand some concepts, and it helps to some point, and then sometimes it goes off the rails, and sometimes I notice that. But I know that like Duolingo is doing some experimentation or with their products involving these language models. I think it's super promising. I'm excited about that.
Let's see. So John, as an economist, for the more economics focused application areas in this list, what do you have to offer our audience?
Well, I would say the only sector that I'm actually a producer in is the higher ed sector. So I would agree with David's point that they can be really powerful for learning. It's a very patient tutor. These other things like marketing and recruiting, and I would kind of say it's probably going to be practitioners and entrepreneurs that are the ones who are going to figure out the use cases. In some of my consulting work, like I've seen some labor market applications around trying to help employers write better job descriptions, some applications around helping candidates write better cover letters. But I think it's we're at an early stage where people are trying to figure out, what exactly you can do with these things, and you really kind of have to get into the nitty-gritty details. I think the economist take tends to operate at a higher level of like trying to understand, well, what did this change the cost of doing? What kind of labor did this make either more productive or something we might substitute away from? So I'm reluctant to kind of get into like any particular application and say, oh, this is the thing, except for the one that I know something about, which is teaching.
But in terms of actually giving us some insight into the issues in that space, you mentioned that economists would think of this in terms of what is it making more or less expensive, or how is it changing kind of the role that these things might play. Can you say anything a little bit more specific in that space to give?
Yeah, I mean, so, I think there was, with the rise of computers, so in the 1960s, there was this idea that it kind of replaced a lot of jobs that were very much like direct substitutes for what computers did. So if you were kind of doing very much like information processing tasks that could now be automated, those jobs were sort of disappear, and it kind of was a complement to people at the high end. So, if I'm an accountant, I can go further now that I have a copy of Excel and I'm not kind of doing like rote calculation, and then kind of left other parts of the labor market pretty much unaffected. I think that with this technology, we're still trying to figure out exactly, say like where it affects things in the distribution. I'd say like one thing that's very challenging is that it's really hard to kind of get a real sense of like what these things can and can't do. And so that makes it really difficult to kind of say, well, this is the kind of task or occupation that's going to either be like adversely affected or complemented. It probably matters a lot like what the precise details are. I do think there's some evidence that these technologies tend to help people who are maybe less skilled or less experienced, that if like you're a true expert, like you're really at the top of your field, these things aren't that helpful. If you make a lot of like rookie mistakes and you're just starting out, it can have a bigger effect. And if that's the case, that's kind of interesting because it suggests these might be inequality reducing technologies. But again, it's very, very early days in trying to understand like what are the big labor market implications of these, and I think it would be imprudent to make any strong predictions.
Yeah, absolutely. Oh, sorry. Before Sameena jumps in, I just wanted to highlight that something that you said, John, addresses a question that I have had. I think it's yet to be seen, but I wonder if this idea of these generative AI technologies being sort of scaffolding for filling in gaps. I wonder the extent to which it creates more opportunities for an inclusive workplace that's more conducive to people with various different disabilities being able to participate more fully in the workplace because it might be more conducive. There might be a way that it just allows people to do things differently so that people have options in terms of how they might do their jobs. I think that's yet to be seen, but I just wanted to kind of add that in, but I want to let Sameena jump in. Go ahead, Sameena.
Thank you, Karen. So I think like taking a step back from this, the question is like, can AI help with all of these things? And the answer is yes, like AI can and is already helping with all of these efforts. Like they're firms that are already employing AI for all of these efforts. They are startups, this is like current scenario, and it has been for like, I want to say like at least several years in all of these spaces as well. Then the question is specific to LLMs and to foundational models. I would say that maybe the question then becomes then that, of course, yes, it can help, but it can probably accelerate all of that AI development in meaningful ways. So from a AI scientist perspective, for the application it seems to be working on, the amount of speed up is quite high. And I'm personally quite excited after seeing the speed up we get. And then I think the other aspect is, to your point, like there were or there are some people who do not, who are not AI scientists, but if now they want to use AI technologies and build themselves, and they have some working knowledge of coding and they have some working knowledge of business processes, it can also produce AI code. And I've seen evidence when non-AI people asked it to generate AI code, but they had some working knowledge and they had proper testing and controls to at least check the output and the domain knowledge to check the output, they were able to iterate and get it to a state that was actually quite accurate. So I think it does open up that market of, like, I think for many things, a game changer is often when from processes or things, large amount of friction is removed. So I do think by this, it enables a large amount of friction that, people like myself, have to an extent gotten automated, that a lot of people can now have working knowledge and can do AI tasks. And it's a good thing, in my opinion. So I think the speed of which we will deploy and employ AI systems more broadly for many use cases, I think I'm personally quite excited about it.
Anton, did you want to jump in? You look like you have something to say.
Yeah, happy to add my few cents. So I want to echo what John and Sameena said. Anything on this list is something that works well as an area of application for these large language models. Now, for work specifically in economics of finance, I also wanted to share a paper of mine in which I go through essentially 25 use cases for how economists and finance researchers can use these language models. And yeah, the area of applicability is really wide. Essentially, any cognitive task that isn't too analytical and that fits into a 4,000 token context window, or if you have access to Claude 100,000 token context window, can usefully draw on these systems. Then I also wanted to say one thing about the effects on skilled versus unskilled workers. So as John mentioned, there have been some preliminary studies that suggest that unskilled workers benefit more from this technology. If we flip that, I guess another way of putting it is to say that the technology is actually de-skilling. It reduces the value of skill, and that's one of the reasons why it helps the unskilled more. And I think there's going to be a whole amount of human capital that will soon be a legacy asset, because language models make it essentially no longer valuable. Just like if you were a taxi driver in London and you had to memorize the street map of London, that's no longer valuable now that we have Google Maps.
I wonder what others think about this issue, because that seems in some sense is an extreme view of the role of generative AI in this particular space. And I wonder what people think about what are the things that professionals in finance and economics are learning now, being trained in now, doing now, that are now superfluous. And some of you have said, oh, my focus is more on education in this space. So maybe this is a good question. So David or John, do you have any, do you agree with this positioning, or do you have like a slightly different angle to bring to the discussion?
Well, I'm not sure I would agree with the characterization of this as de-skilling. And I would use an analogy to say, to consider carpenters, right? If you went back 100 years, you were drilling and cutting everything by hand. And now you have a power drill and a skill saw. Would we say that was de-skilling? I don't think so. I think it kind of took the tedious part of the job and allowed you to do it much, much more quickly. Now, I think you could imagine, you could certainly give me other analogies or other scenarios that would kind of fit Anton's framing as de-skilling. But to me, at least, the, say, code completion type applications seem much more like power tools than robot carpenter.
David, what is your take?
I guess the part that I think about a lot, which is related to, taxi drivers not needing to understand street maps anymore. And that may well be true, but in a slightly broader sense, like, is it still useful to have knowledge in our heads in the era of search engines or GPTs? And similarly, is this kind of, never mind, I won't go that way. And I think it is important to have knowledge, because it's, you can't really reason without having, in my opinion, the kind of ideas in your head and knowing what ideas to put together. You kind of have to know what's out there to go search for it and then come up with some new conclusion. I don't know if there's an analog specifically for taxi driver, but I think I'll just leave it there.
Yeah, I would say it's true. So every Uber and Lyft driver is using Google Maps these days, as far as I can tell from my experience using these services. And yet, I would say that I have heard and have experienced lots of shortcomings of the service provided when people just don't know the area that they're taking.
Definitely agree with that.
Rely on
terrible choices based on Google Maps.
Yeah. And also, I could go on and on. Like, what about Google Maps when you're walking in a city that you've never been in before? I've had lots of those experiences, and I can tell you lots of ways in which it's suboptimal. And so I do think that maps and other sources of information about how to get around are things that if we just lost them, we would suffer as a result. I have heard another person say, though, well, okay, that might be true in an ideal world, but does that mean that we won't lose those things because maybe it feels cheaper and easier to kind of defer, and maybe people would make those choices? Again, I think we have choices, and I think we have to be very involved in the decision making in these spaces about which directions we will ultimately go. So I think we could continue. Yes.
Not to be.
Go right ahead, John.
So much of an economist here, but I mean, I think that this is something that markets do a pretty good job of figuring out. Say like in the case of, say, like GPS support. I mean, you can watch those videos of these, London cab drivers, and they're taking years of their lives trying to memorize this information that, is something that a computer can actually do pretty well. Maybe not as well as sort of the best person, and so. This is something that people kind of say, well, yes, maybe this is like a slightly inferior product, but the cost is so much better that it kind of wins in the market. And so, I think a lot of things kind of, markets kind of take care of this question of like, how important is it to be super, super skilled at this thing? And, is the automated manufactured version kind of good enough for most people that, the other thing sort of disappears?
Yeah, and I think to your point, Carolyn, the earlier point that you made, also to just tag on to John's point, like there are probably people who don't have good memory. So then this is a good tool, right? Then it really challenges you to like, was memory the main thing, or was good decisioning the main thing? Like, what is the actual value proposition of the end-to-end task?
Yeah, well, I just want to bring in a slight insight from the area of education, which is, if we have calculators, do we still have to memorize our math facts? And I think that what we know is that if kids don't memorize their math facts, they're not able to layer the conceptual understanding of math over that. So even if we say, okay, so then we can offload the more mechanical aspects of processes, and we'll do the decision-making parts of it. Are we able to do that as well if we haven't kind of moved up through these lower levels to higher levels in our training? And I think that those things are yet to be seen. And that doesn't draw specifically from areas of finance and economics, but to the extent that, we're drawing inferences from what is known from, say, the field of learning sciences to what, decisions we may make about the future in this area. I think that those insights are relevant even if they come from a different field. It sounds like we have some different opinions around the table of where things will ultimately lie. I like what John has brought in, though, as an economist, that let the market decide is going to give us a good result, and we should find comfort in that. Does anybody want to respond to that? Does everyone believe that that's true? Anton wants to jump in.
I wanted to say, I do believe that just like there are tasks that will be complemented and tasks that will be substituted, and there's going to be workers who will be complemented and workers who are going to be more substituted, there's also going to be skills that will be more complemented and skills that will be more substituted. And I guess the one more piece I want to add to that is that is true for the current generation of models. And if we fast forward another 6 months or another 12 months, and progress is happening so fast here, it's going to be yet a different set of skills and a different set of workers who will be affected then. So anything we are saying now is true for the present, and it's really hard to predict what is going to be true in a year or two from now.
I like that answer too. It seems like there's a lot of nuance here, and I think we have to gather more data, and a lot of we're going to find out how things are going to go, and so maybe we shouldn't just make assumptions about what the future will be. Let's look at and then some future looking comments and questions that have been posted earlier by our audience. So when you think specifically of the areas of finance and economics, where do you see the locus of major change being? Is it coming from industry or certain industries even? Or is it coming from the universities? Is it coming from the market? So which is like everyone deciding which services they pay for or not? Or another way of asking the question is, who are the big innovators in this space? So where will the big new usages in this space come from? So let's go around the table and see what people have to say about this question. Let's start with Sean. We haven't heard from you in a while.
Okay, yeah, thanks. So yeah, maybe for this one, like I can actually ask something that I'm curious about to the other panelists. So there's this trend of kind of consolidation of like the very largest language models in different organizations. And so I'm curious in an area like finance, where it's kind of a more expert domain, which might differ from like training on general web data. And it might have some unique challenges, things around, privacy, correctness, things like that. I'm curious, like in the future, how do you see these very large language models? Like, do these need to be developed kind of in-house for particular expert domains? Do you see it as, being able to use them as a kind of utility from a different company? Yeah, I guess I'd be really curious about that.
Great. So, and we'll hear what the other panelists have to say about these nuances of the question, as well as the original question. David, would you like to jump in next?
I only remember Sean's question, but not so much the original question.
Oh, can you not see my question on the screen?
Oh, I probably just not enough screens. Okay.
It's the first one. Or you can just answer.
I don't know the answer to that question. It's really interesting. Where the locus of change? I think in general these days it's like, what's the role of academia? Can they kind of compete with these big industrial labs? I think my position is yes, but they shouldn't be doing the exact same things necessarily. So, I mean, in finance and economics, there are academic institutes or portions of them that are really interested in finance, and I think they're doing really interesting work. I don't know. As for Sean's question, which I've thought a lot about, like, is there a role for these generic models, these big models that do everything in specific niche applications like finance? I think it's a bit of an open question. So we were doing an experiment at Bloomberg, which was to say, well, maybe that's not the case. Maybe we need to train on kind of finance specific data from the beginning to get the best performance. But that's only half the experiment, because the next half is to figure out a way to take a general purpose model and call it domain adapted, say, continue it more with finance specific data and do a comparison. And so we're only halfway through that experiment, and I think it remains to be seen. Yeah, a lot of people talk about, but I'll stop there.
That's interesting, because I think that it shows that in terms of where will the innovation come from? Obviously, we're all being speculative in this place. We can't know for sure. These are questions, as you have pointed out, that a lot of people are asking themselves, and some people in their own sectors are saying, should I just defer to the big companies and just let them, create the future because they have resources that other sectors like startup companies would not have access to, or even universities would have less access to. I think what you're pointing to is the fact that, that's just oversimplifying the question, because we're assuming that the only way to get to the behavior we want is by building massive models on the biggest data sets. And yet in certain areas, it may not be the case. And I think we've seen this history with search. One of my colleagues whose specialty is search brought this out at an earlier panel in a different context, that yes, Google kind of took over search in some sense for general search that most people use every day, multiple times, but there are specific verticals where that isn't going to solve the problem, and where more specialized solutions are needed. Those are absolutely important. They might not be, used by as many people, but the people who need them really need them, and they really need to have specialized expertise. And those things will continue to be important in the world. And so I think, again, I think we're calling for some nuance here. There's not a one size fits all solution. John, would you like to jump in?
I would. Are we allowed to go to questions further down the stack?
Sure. Why don't you do that?
Okay. I'm very skeptical that we're going to see mass technological unemployment from this, because I think that there's really no historical precedent for that happening. I think it's different workers get affected in different ways, and people adjust. I think a world in which we do see, say, massive productivity increases from these tools. There's also a world that's a lot wealthier. People will be interested in buying other things, and sort of new types of jobs will emerge, and new industries will emerge that take advantage of these models. So it's just not something that I'm worried about.
Great. If we shift on to, say, the changing landscape of employment, then one thing I'll point out is that has been a question that I have heard people asking recently. They are aware that there have been massive waves of layoffs in industry at some of the big companies that are also developing big models and have large scale compute. And some people have made a connection between these two, and they've said, oh, maybe these massive layoffs are because all these people are being replaced by AI. I think that's probably complete.
I don't think so. I don't think the timing's right. I don't think I think a shorthand history here is that Silicon Valley overhired during the pandemic, and we're kind of seeing that. But I mean, you kind of have to look at the economy as a whole. The unemployment rate right now is very, very low. We have wages rising at the low end of the distribution. I mean, it's a very good economy right now, objectively. So I mean, I think in some ways, academics and people like ourselves, we're kind of inclined to focus on the things that are new and interesting, and maybe that makes us think that they're a bigger deal economy-wide than they are, at least in the moment. Anton could be right, and in the future things are completely different. But right now, I just don't think they're having an impact on the economy writ large. I think you can find news stories of saying like, oh, we used to hire content writers, and now we're going to use ChatGPT. But I think if you're trying to think about the economy as a whole, that kind of anecdotal focus is really a distraction, and will cause you to kind of miss what's actually happening in the world.
So John, can you actually expand on that slightly, since you are an economist and you must be tapped in to the discourse among economists on this issue? Are there people who are studying, where in the economy is this having an impact, and how big will that impact be? And how are they actually doing that work? So you're pointing to what we see in the media as these sort of cherry-picked examples. How should we be asking this question? What would it take?
Well, I mean, I think what you're seeing now, I mean, I'm definitely doing this myself, is, doing basically experiments with workers and like looking at their productivity. So some grad students at MIT did this with a bunch of knowledge worker tasks, and randomized them to have access to GPT 3.5 and sort of see, what does it do to their productivity. I think, longer term, you'll start to see people trying to look and see if this shows up in aggregate statistics that we collect. But I would say right now, most of the work is, like, oh, let's look what happened at this call center. Let's look what happened in this company that did an RCT. Trying to get to the kind of micro details of what it does to productivity. Aggregating up to the whole economy, it's too early to do that.
Anton, did you want to have any counterpoint to that?
I actually do very much want to agree on that with Sean. I do think right now we're seeing, just very small fluctuations that are generated by generative AI. It doesn't mean that that won't change in the near future, as people are trying to figure out how to use these systems and how to deploy them in ways that are going to displace workers in a more wholesale manner. I also wanted to say something more specific about this question of large language models affecting the finance sector. So one of the things that is so interesting is that finance has always been at the forefront of employing the quantitative type of AI that we have seen advance rapidly in prior decades. And so in some sense, you can say finance is tacked up as much as they could be, because that's where the money is. And this latest generation of systems, large language models, they are much better with qualitative things. And for that reason, I think the impact on the finance sector is actually going to be less than the impact on other sectors like education and potentially even healthcare. So there is no doubt in my mind that anybody working in finance has to kind of arm up and make sure that they are using these latest generation of language models. But I think overall the impact on the sector is not going to be as strong as it will be for other sectors.
Sameena, do you want to join in from the finance side of that? When you think, I know that the AI group at JPMorgan is thinking about all areas of banking where AI can be applied. And so I think that you're very tapped into those discussions and can speak to at least the answer to the question from the standpoint of large banking firms. How much of an impact on the inner workings of these firms will these advances make? And also kind of over what period of time? Is it that it's already happening, or we're getting ready, but it hasn't really happened yet, and maybe 10 years from now? So where are we kind of on this spectrum?
So I think from my perspective, it is already happening, and it has been happening for a few years already. I do want to, in part connected with what has already been said, that while the nature of the exact tasks you are doing on a day-to-day basis will evolve, and maybe you will stop doing other tasks, and maybe you will, start focusing on other kind of higher value added things, or maybe the definition of higher value added things will evolve with time. But whether there is a future in which, it's all self-autonomous and we get to put our feet up on the table and watch, I doubt that will happen. But I do think the actual definition of jobs may change. And I do think there might be Some roles that we are thinking of as verticals, they will become more horizontals. Some job functions we may think like actually instead of these 5, now it's actually like one job function that then can transform this to this at the end. So I think the exact nature of jobs will evolve, and we should be ready for that, as we should be ready for any change in our lives. I think automation is a good thing, and as John was saying, like it actually produces wealth, and I buy into that concept, and I think it's a great leveler, and I think it's a great way for people to move up, and it will open up a lot of flywheel kind of opportunities that we haven't even imagined. I mean, an example I give is the old days when people used to place phone calls and we had these telephone operators. At that time, when that thing about moving a cord from here to there got replaced by machines, maybe we thought of it as a 1:1 replacement. But over time, like think of the evolution that happened, and with smartphones and app stores and the applications that got built and the wealth that got generated and the kind of all ecosystem that gets unlocked because of these flywheel effects. Like we cannot imagine that. But I do think all of those things will happen at some point.
David, do you have anything to add to what Sameena has said from the standpoint of financial institutions?
No, I think she did a fine job. I have to drop off in a few minutes. I don't know if I should just say my thank yous and goodbyes now, or.
Let's hear your concluding remarks, and then we'll go around the table.
Well, I just really enjoyed the discussion, and it was great questions, and I learned a lot. I think just keep a realistic expectation on what these large language models can do, and stay flexible and optimistic. And I think things are going in a good direction. That's my opinion.
Great. Thank you so much, David. I want to bring Sean back into the conversation now, because we've been talking about applications in the area of finance and economics. Sean does a lot of work in the area of large language models and math in particular. One challenge I know with large language models, and I think John may have brought this in, or maybe it was Anton or both, about how language models in general are very good at the sort of qualitative aspects of the reasoning that that we're interested in. And maybe we need to have call outs to, and I think Sean was talking about some ways of doing call outs to other platforms and applications and techniques for doing the quantitative reasoning. But I think a challenge has been on bringing those worlds together, and very many of the tasks in the finance space that I'm aware of involve the interplay between the text around these quantitative expressions and the understanding of the expressions themselves, and in particular, using that understanding of the context to understand even what's being asked of those quantitative expressions. And at least from my vantage point, and feel free to tell me that I'm not aware of recent advances in this space, but it seems like that idea of how do we actually capture the interplay is still very much an open question. So I'd like to hear first from Sean, where he sees work in that space and potential in that area, because I'm pretty sure that he has seen this in his own work, and then I'll ask others to weigh in. Sean, why don't you kick us off?
Yeah, that's a great question. So yeah, like others have said, there's this kind of distinction, maybe you could call it like symbolic or formal tasks, and then more informal ones. And what these language models appear to be pretty good at is at least coming up with some ideas for these more informal aspects of the task. And so this might be like sketching some solution or some like structure of code. And then that's kind of useful for a human to maybe like change the way they're thinking about a problem. And so I think, yeah, things like this are very much an active area of research, be it in code generation, in mathematics, the areas that I talked about. And so, yeah, I think the flexibility of these models makes them really interesting for kind of serving as an interface between these tasks that we can offload to a more reliable system, and then the ones that are kind of more hard to capture in some algorithm.
Anton, would you like to respond to that?
I'm afraid I don't have much to add to that, but I agree that that's a really interesting area of work and a big challenge that we'll have to tackle soon.
Great. I think I'm going to start to bring this discussion to a close now. And so we'll go around the table with our remaining panelists to have them give their closing remarks, and then I'll just make a few announcements about opportunities coming up. John, would you like to give your closing remarks?
Sure. Thanks for having me. This was really fun and interesting. I mean, I think, you know, my closing remark is probably that we should all stay pretty humble. Predicting the future is very, very difficult. And, you know, I think one thing that makes it particularly difficult here, and Anton kind of hit on this quite a bit, is, you know, we are in a stage where we see lots and lots of advances happening very quickly. And that makes it really hard to know how this shakes out. Now, that's not to say that it's not worthwhile to try and to think through things. It's just, I certainly feel pretty humble and reluctant to make any strong predictions. I think, you know, in earlier stages of technological development, it sometimes maybe the full implications of some technology weren't clear, but we kind of knew what it could do. And I think that's one of the things that's difficult about this technology. If you press technologists like, okay, well, tell me what these models can't do, you know, draw a ceiling for me. They won't say. And so, you know, I think that makes it very difficult to make predictions when it's really, even the people who are the experts are unclear about what's possible.
That's a really great point. And I'm one of those people who is reluctant to say that anything is impossible, but how long will it take us to get there? How long have we been saying that speech recognition is going to be solved in the next 5-10 years? And yet there have been great advances in that space, and yet it's still an active area of research. So I think similarly, you know, where will that asymptote converge? Who knows? Sean, would you like to jump in with your concluding remarks?
Yeah, so maybe just to add one more thing, and again, it's more from a research perspective, but one really exciting thing about this time has been there's kind of a really vibrant community now of people working on these problems. So we've seen like rapid advances in the kind of open source community, trying to either reproduce certain results or experiment with different things. And so like right now, as we speak, there's people kind of trying out new algorithms, trying out new evaluation methods, things like that. And so I think it's a really exciting time from a research perspective. And then even the fact that we're kind of all gathered here, talking about like the potential for these type of methods in these different industries, I think it's a really exciting time. So that's the way I look at it.
Great. And we're excited to have you among us, Sean, to help push that future forward. Anton, how about you for your closing remarks?
Yeah, I strongly agree with John that it is so hard to make specific predictions and have this really, you know, speaking like an economist, this really wide probability distribution of potential outcomes. Now, one thing I'll say, I also agree that there isn't any clear upper limit of what these systems may be able to do. And what that tells me is that we should keep an eye on the possibility that we will reach artificial general intelligence systems that can do essentially everything in the foreseeable future. And if that happens, of course, the implications for our society and our world are going to be really transformative. And I think it really is worth spending a lot of our thoughts and brain power as researchers on what we can do to ensure that this possibility turns out well for us as humanity. And if things turn out along the more conservative scenarios, that we are just more productive in 5 years from now, but nothing much else has changed, then in some ways I would be very happy about that. And I wouldn't be particularly concerned. But the more transformative scenarios are actually quite scary. And then as kind of my last act in this panel conversation, I wanted to thank you, Carolyn, for moderating this really interesting conversation. And for anybody who doesn't quite know how their professional future will shape out in the face of these transformations.
Oh, you muted yourself, Anton.
Oh, sorry, for anybody who doesn't quite know how their professional future will shape out in the face of these transformative changes, I wanted to share a potential weekend reading that you may find interesting.
Oh yeah, go ahead and place that in the chat. I think
it's a paper on preparing for the non-existent future of work.
I hope that doesn't mean that the future where there is no work.
That's exactly what it means. Yeah.
Okay. Well, anyway, we have a variety of perspectives on this panel. Okay, Sameena, you have the privileged position of being our final panelist to give their concluding remarks, and we're very much excited to hear what you have to say.
Thank you. I think I agree with almost everything that has been said. And it is hard to predict long-term future for sure. But I do think some of these things that have happened over the last few months have moved at a very, very fast pace. And I think, even as people who have been in the field for a very, very long time and used to learning fast and things like that, it has been overwhelming to keep up pace with all the innovations that have been happening. And I do think the idea of having smaller sized specialist models that people have put out like at a rapid pace and are able to do extremely well on, a smaller set of wide variety of tasks is very compelling. And the other big, I think, compelling thing in my opinion is this idea of lang chain. And then you could chain other types of things on top, which then opens up a very, very broad range of possibilities and overcoming all of these shortcomings and things like that. So I think that is also an area to watch for and contribute to. I do think AGI is not out of the realm of possibility, depending on the definition of AGI and how we define it. I don't think with this emotions and things like that I'm bought into that at all. But the idea of intelligence is it depends on how you define it. You can simulate it. And we also sometimes, I think, what is the word? I think we think of humans as better than they actually are in many cases. So I think there is also a wide range of human potential, and we think humans are very good at certain things when we are not. So I do think AI is better than us on many tasks, and it's basically about human AI combination, and it's a spectrum. And the best solutions are the ones in which humans are optimized for the tasks that humans are better on, and AI is optimized for the tasks that AI is better on. And I do think future of work will evolve productivity and changing the nature of jobs and things like that. But that is also right now it's AI, but previously it was other things. And humans are very robust and resilient, and we adapt. So in 10 years, it will be a non-issue. It will be, we would have overcome it and we wouldn't be paying attention.
Yeah, lots of good points there. But I think overall, it's a common theme among all of our panelists, regardless of the difference in their perspectives on what is the ultimate capability we can expect to see, how quickly will we see it. I think everyone is very calm looking to the future. I think Anton has raised a cautionary note, and I think that we all believe that we need to be watchful and careful, and this idea of responsibility, human responsibility to be involved and just to make sure that things work out for the good of on all dimensions. We all believe in that. And so I think that we're working together to make sure that things come to a reasonable progression. And I think that's comforting. And I hope that people find that encouraging. I have gotten a little bit of back channel, an email and a chat of, in these topic focuses, why do we keep going to generalities? But I think that there are a lot of sort of undercurrents of big issues that are cross-cutting and that have come up in all of these sectors. And we have experts that are really grounded in the details of education first, then medicine and public health, and today finance and economics. And yet there's a lot of crosstalk across these panels in ways in which we're still waiting in all of these sectors to see how things are going to play out. And so we keep coming back to these broad general questions that we all need to grapple with. So moving into just a couple of announcements as we wrap up. I think we raised a lot of big issues today, and I would love to hear what people have to say about that and to continue the conversation. And so if you come to this Gen AI Reflect page, and again, give us your reflections on today's discussion and what new questions it raised in your minds and concerns, ideas. But also, if you would like to indicate that you want to be included in our Slack, you can be part of ongoing discussions. And I have noticed an uptick in those discussions. I'm very happy with the level of activity. Also just want to remind you of the Certificate in Computational Data Science Foundations. For those of you from a little bit technical background, maybe you have some skills in programming, but you want to get more into modeling and working with data and building models, this certificate might be for you. And if you come to this page, bit.ly CMU CDS, you can indicate your interest and more information will be sent your way. I want to remind you also that tomorrow there will be an activity related to our first hackathon series. And then there will be today registration for finance and economics as a hackathon is also opening, and the medicine and public health is still open. And I really want to encourage you to come to our website and sign up for these hackathons. It's a way of kind of really getting a tangible sense of these issues of like, what is the capability we can get to? If you don't know yet sort of how to even work with these models, come to one of our tutorials and get up to speed. But if you have any sort of level of hands-on experience with programming, you can get involved in a team, even if you don't have deep expertise in large language models, and really get that up close and personal view of what's possible, and to try to build out some of your ideas and have a hand in shaping our future. So I strongly encourage people to go ahead and sign up and get involved. Like I said earlier, the first hackathon registration for that one, Education in the Future Work, is closed. It's over full, and we're happy about the large number of people who have signed up to participate. And now we'd like to encourage others to join in for the medicine and public health hackathon or the finance and economics. If you come to our website and click on the hackathons link, you'll come to the page that talks about the three and also offers sub parts of the page that are about the three different ones. And each one has, each one except for the first one has an active registration button now. I know that there were a couple of issues with the buttons, registration for medicine and public health and also finance and economics. This past week, we got some messages about that, but we have fixed those on the website, and we have verified that they are fully functioning now. So thank you all for being part of this discussion. I hope it was informative. I hope it was hope-giving, and I hope to see many of you at our upcoming events. Keep your eye on the website and continue to participate in the community. And I will see you.